Hi, my name is Devi Priya. Uh, Today we are going to discuss about the thing which is called as UV spectroscopy. So under UV spectroscopy, the contents we are going to cover is introduction, principle, pair numbers, instrumentation, single beam spectrophotometer, double beam spectrophotometer, and its differences and applications. And first of all, today we're going to discuss about the introduction of UV visible spectroscopy. Firstly, we need to know about what is meant by spectroscopy. Spectroscopy is nothing but it is a branch of science that deals with the interaction of matter with light. That is the main definition of spectroscopy. And UV visible spectroscopy, we need to know about the wavelength region. The wavelength range of UV radiation, that is ultraviolet radiation, is between 200 nanometers to 400 nanometers, and this UV radiation is again divided into two types. One is near ultraviolet region and far ultraviolet region. The region between 200 nanometers to 400 nanometers is called as near ultraviolet region, and below 200 nanometers is called as far ultraviolet region. And for visible radiation, it is between 400 nanometers to 800 nanometers. And if the wavelength of this UV and visible region is always expressed in nanometers or in angstroms. Okay, whether you can say nanometers or in angstroms. And the absorption is expressed in the terms of wave number. And the main thing which is involved in UV spectrophotometer is, so the electrons or molecules is always in the ground state. When we give radiation in the form of ultraviolet region, it will absorb this energy and it undergoes transitions from ground state to excited state. As in excited state, the energy is unstable. The electrons or molecules come back to the ground state by emission of radiation. That is the main thing which is involved in ultraviolet visible spectrophotometer. Radiation in this region is of sufficient energy to cause electronic transition of the outer electrons, and both organic and inorganic species exhibit these electronic transitions in which the outermost electrons, okay, the electron outermost layer have are promoted to higher energy levels, and here these electronic transitions, as we said that it undergoes transitions from ground state to excited state. It goes from ground state to excited state, whether in the form of vibration. So through vibration it goes to the higher state, as well as rotational form. It undergoes rotational form, goes to the higher energy level. And if a compound appears colored in the analysis, if it is selectively absorbed this visible region, if a compound absorbs this radiation which ranges from 400 to 800 nanometers, it produces color. If no color is produced, it means it comes under the UV region. And the main function of this absorbed energy is to raise the molecule from the ground energy state to higher excited energy state. And the differences of these energies, that is from ground state to excited state, is given as delta E is equals to E1 minus E0 is equals to HV is equals to Hc by lambda. The delta E is nothing but the energy, E1 is nothing but excited state, E0 is nothing but the ground state energy level, and that is a constant. And this delta E depends upon how tightly the electrons are bound in the bonds, and accordingly absorption will occur in UV or visible range. For example, so this absorption and transitions will be mainly based upon how tightly the electrons are bonded to the outermost layer of the molecule. And if the electrons of a molecules are tightly bound, as in compounds containing sigma bond, if it consists of a sigma bonds, it comes under the saturated compounds.